Hello everyone. In today's lecture, we will see the problems based on eigenvalues and eigenvectors. So last class, we have seen the first type, non-symmetric matrices with non-repeated eigenvalues. So in this lecture, we will see symmetric matrices with non-repeated eigenvalues. See, I have given with the problem. Find the eigenvalues and eigenvectors of a matrix is given 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. So when you observe, this is a symmetric matrix. So now you all can recall the concept of a symmetric matrix. That is, if you interchange the rows and columns, the matrix will remain the same. That is called as symmetric matrices. So as usual, when you do it, let the given matrix be A. I start the solution here. So I am taking the given matrix as A. Now to find the characteristic equation, S1 equal to sum of diagonal elements. So when I do the sum of diagonal elements, it is 8 plus 7 plus 3, which is nothing but 18. And S2 is sum of minors of diagonal elements. So first diagonal element is 8. Leaving the corresponding row and column, I have to take the determinant. So it is 7 minus 4 3 sum, as it is given as sum. So plus next diagonal element is 7. I have to leave the corresponding row and column. When I leave, I get 8 2 2 3 plus next diagonal element is 3. So it is 8 minus 6 7. So when you expand the determinant, we get 21 minus 16 plus 24 minus 4 plus 56 minus 36. So the answer we get as 45. Now to find out S3, we all know that it is determinant of A. So I want to expand the given matrix A. So 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. So 8 times I am going to expand along the first row. So it is 8 times, leaving the corresponding row and column, I get 7 minus 4 3. Then minus of the next element, that is the element A12. Minus 6 of minus 6 minus 4 2 3 plus 2 times this 2. Okay, 2 times where you have to leave the corresponding row and column. So you get minus 6 7 2 minus 4. So expanding the determinant, it is 7 3s are 21 and 4 4s are 16, and minus into minus here becomes plus, and this is minus 18, and this is minus into minus, it is plus 8, plus 2 into this is 24 minus 14. So you get the answer becomes 0. Now we all know the characteristic equation formula. It is lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. When I substitute S1, S2, S3, so S1 is 18 and S2 is 45 and S3 becomes 0. So the last, finally we get the characteristic equation as 8 lambda cube minus 18 lambda squared plus 45 lambda equal to 0. Next we are going to solve this characteristic equation and we are going to find out the eigenvalues and eigenvalues of this equation. See, to solve this, so when I observe this characteristic equation, this all three elements have a lambda in common. So I can take one lambda common outside. So I get lambda squared minus 18 lambda plus 45 equal to 0. So this means lambda equal to 0, or lambda squared minus 18 lambda plus 45 equal to 0. So when I solve this equation, lambda squared minus 18 lambda plus 45 equal to 0, I get lambda minus 3 into lambda minus 15 equal to 0. So lambda takes the value 3, 15. So on the whole, when I observe, lambda is 0, 3, 15. So at this point, you have to see whether the eigenvalues are repeated or non-repeated. So here the eigenvalues are non-repeated. So this is what the topic we are seeing today, symmetric matrices with non-repeated eigenvalues. So in the given question, the matrix is a symmetric matrix, but while solving, we are reaching non-repeated eigenvalues. Now we want to find the eigenvector. To find the eigenvector, so first case 1 I am taking lambda equal to 0. a minus lambda I into x equal to 0. So when I put lambda is 0, it becomes ax equal to 0. So a is nothing but the given matrix, and capital X is x1, x2, x3 equal to 0. Now let me select the last two rows. So x1, x2, x3 I will write. So when I want to write x1, I will write, I have to omit this first column. So I write 7 minus 4 minus 4 3. And when I do with x2, I have to leave the corresponding second column. So I get minus 6 and 2 here. And third x3 when I take, I get 7 minus 4. So it is x1 by just the cross multiplication, 21 minus 16 equal to x2 by minus 8 plus 18 and x3 by 24 minus 14. So it is nothing but x1 by 5 equal to x2 by 10 equal to x3 by 10. When divided by 5 I get, that is for simplification purpose, when we divide by 5 I get x1 by 1, x2 by 2, x3 by 2. So the eigenvector capital X1 is equal to 1, 2, 2. So this is the first eigenvector. So similarly we are going to find the next two eigenvectors using the next eigenvalues 3 and 15. Now case 2, lambda equal to 3. A minus lambda into x equal to 0. Now substitute lambda value as 3 here. So when I put lambda value as 3, it becomes, when I perform A minus 3, I is nothing but the identity matrix. So from the matrix A, I want to substitute 3 times the identity. From the matrix A, I want to subtract 3 times the identity matrix. So I get 8 minus 3, 7 minus 3, 3 minus 3 in the diagonal. All other elements will remain the same. In times x1, x2, x3 equal to 0. So the resultant matrix I get as 5 minus 6, 2, minus 6, 4 minus 4, 2 minus 4, 0. Now selecting the last two rows, as such we will write x1, x2, x3. So when I want to write below x1, I will skip this first column. I get 4 minus 4 minus 4, 0. When I write below x2, I will skip this one. So already minus 4, 0 is there. So I can write minus 6, 2. So x3, below x3, when I want to write, I will skip this one. This is I want to skip this row and I will check minus 6, 2 is there. So 4 minus 4 I have to write. So by cross multiplication I get x1 by 0 minus 16 equal to x2 by minus 8 minus 0, x3 by 24 minus 8. So it is x1 by minus 16, x2 by minus 8, x3 by 16. So upon simplification we get x2 vector as 2, 1, minus 2. See, when I just divide by minus 8, I get 2, 1, minus 2 here. So this is x2. Now moving to the last case, lambda equal to 15. I get a minus lambda I into x equal to 0. So a minus 15i into x equal to 0. That is, from the matrix A, I want to subtract 15 times the identity matrix. So we all know that when it is 15i, we get only the element 15 in the identity, the element 15 in the diagonal. So it will be 8 minus 15 minus 6, 2, minus 6, 7, minus 15, minus 4, 2 minus 4, 3 minus 15 times x1, x2, x3 equal to 0. So I get 7 minus 6, 2 minus 6, 8 minus 4, 2 minus 4 minus 12. So as such, how we explain the last two rows, no? The same way, x1, x2, x3, last two rows let me take. So I get minus 8, minus 4, minus 4, minus 12, minus 6, 2, minus 8, minus 4. Now x1 by, it is 96 minus 16, just the cross multiplication of the below elements. x2 divided by minus 8 minus 72, x3 divided by, so I get 80 minus 80, 40. So upon simplification of dividing by 40, I get x1 by 2, x2 by minus 2 and x3 by 1. So the third eigenvector is x3 equal to 2 minus 2, 1. So this is how we find the eigenvalue and eigenvector of symmetric matrices with non-repeated eigenvalues. We will see the next two cases in the next two types in the next session. Thank you.